Welcome to today's GATE video. I am Dr.L.UMASANKar, Associate Professor, SY Engineering College, Electrical Engineering Department. So today, going to explain about power system analysis subject. In the power system analysis, the important topics: symmetrical and unsymmetrical fault analysis. So what is meant by fault analysis? So fault analysis is nothing but study of abnormal operation in power system when an unintended electrical connection occurs between the phases or between the phase and ground. So this is nothing but called as fault analysis. So what is the causes of faults? So different type of reasons are available. For example, cable breakdown is also create a fault. Flashover takes place in the conductor or insulator due to lightning initiation, and tree falling, and due to the construction activity and high speed wind also create line to line fault, and vehicle collision, that is also damage the conductors, that will create a fault. So these are the reason creating the faults. So what is the necessity of fault analysis? The purpose of fault analysis is design the circuit breaker, or otherwise selection of circuit breaker, relay protection design, equipment design, system stability studies, and grounding system design, and safety of personal equipment. Because during the fault, huge amount of current will flow through the conductor. We know very well the power system network consists of many number of equipments, that is costliest equipment. So to protect the costliest equipment, we have to use some protective devices, that is circuit breakers and switch gears. The circuit breakers depends the relay, okay, so that we have to calculate the breaking capacity of the circuit breaker, and rating of the switch gear also vary depends upon the fault current. Similarly, relay protection design, it's very important. What is the pickup value of relay? That is different, that is vary depends upon the nature of type of current. Clear? And equipment design, thermal rating of the conductor, busbar rating of the conductor, mechanical strength of the conductor is also vary depends upon the fault type. Okay. System stability studies, we have to analyze behavior of the circuit. So what is the behavior of the circuit when any symmetrical fault current occurs or unsymmetrical fault current occurs? We will discuss later what is the difference between symmetrical fault current and unsymmetrical fault current. So different type of fault currents are created or occurring in the power system network, so that analyzing the system behavior is also, it's very important. And grounding system design, what is the earth fault current value, calculate the earth fault current, and calculate the neutral grounding resistor value, that is also important. And safety of personnel and equipment. So due to the fault, high amount of current will flow, right? That will create arc flash or equipment explosion. So that only these are the parameters are important during the fault analysis. Okay. So different types of faults are available. So one is open circuit fault, The another one is short circuit fault. So open circuit fault, different types, that is one conductor is open, or two conductor is open, or three conductors are open. So what is when we open circuit fault? So open circuit means open circuit fault is nothing but a series fault. One or more conductors become open. That is called as open circuit fault. So in this example, the phase A is open. It may be due to the fuse blown out. It may be fuse blown out, or otherwise the conductor is damaged, will create open circuit fault. So the effect of open circuit fault is voltage is imbalanced and overheating is occurred in the rotating machine and reduce the system performance. So this is the effect of open circuit fault. But the current values decrease in open circuit fault compared with the short circuit fault. In short circuit, the current value is very high. So all the three phases are short circuited. There is nothing but triple line, or otherwise triple line to ground is also one of the classification of symmetrical fault. Okay, so in symmetrical fault, all the fault current values are equal in all the phases, in all the three phases, so that it is a balanced one. Okay, and also the phase displacement between the phases also equal, so that only we can say it's nothing but symmetrical fault. So in this case, in symmetrical fault, we are using positive sequence network. So the occurrence of symmetrical fault is very rare, but it is a most severe fault. The next one is unsymmetrical fault. Unsymmetrical fault classified as single line to ground fault, line to line fault, and double line to ground fault. So single line to ground fault, so in this example, B phase short circuited with the ground is called as single line to ground fault. Line to line fault means two lines are short circuited. Two lines are short circuited is called as line to line fault. Next, double line to ground fault means two lines are simultaneously grounded. Two lines are simultaneously grounded is called as double line to ground fault. In unsymmetrical case, all the fault current values are not equal, and also the phase displacement between the phases also not equal. So that only it is called as unbalanced fault. Unsymmetrical fault is otherwise called as unbalanced fault. Okay, and one more point is important. In symmetrical fault case, all the three phases carrying the equal amount of fault current, right? So that we can calculate IF using any one of the IF is equal to V Thevenin divided by Z Thevenin plus ZF. So what is the difference between open circuit fault is otherwise called as series fault, short circuit fault is otherwise called shunt fault. So in open circuit, current value is very less compared with the short circuit, but in the short circuit current value is huge, and it caused by broken the conductor. Here it caused by face to face or face to ground contact. and less severity. Open circuit fault is less severity, that's what I mentioned, less importance, but short circuit fault is more severe and dangerous. So there is a difference between open circuit fault and short circuit fault. And frequency of occurrence. So in three-phase line to ground fault is nothing but a symmetrical type. So the probability of occurrence is 2 to 3%. But in three-phase line to line fault, again it is nothing but symmetrical case. Okay, here the probability of occurrence is less than 1%. In single line to ground fault is unsymmetrical case. This is frequently occurring, but probability of occurrence is 70%. Okay, compared to three-phase line to ground fault, it's nothing but severity is less, but more frequently occur. Clear? Line to line fault. So frequent probability of occurrence is 15 to 20%, and double line to ground fault is also unsymmetrical type. The frequency of occurrence is less than 10%. So symmetrical fault is very rare but most severe. But unsymmetrical case, single line to ground fault is less severe but frequency of occurrence is more. Okay, that is the difference between unsymmetrical and symmetrical fault. So this is one of the example problem in symmetrical fault analysis. So symmetrical fault occurs on bus 4 of system. Determine fault current, post fault voltages and line current. So here, using Z bus building algorithm, I can calculate the fault current. Okay, so we know very well Z bus building algorithm. Four cases are available. One is reference to new, the next one is existing to new, next one is existing to reference, and another case is existing to existing. So based on that, we can calculate Z bus or determine the Z bus. So here in this problem, first of all, draw the reactance diagram, then apply the Z bus building algorithm. Okay. So this is the reactance diagram for the problem, for the given problem. Okay. So here, this is generator 1, transformer T1, this is L1 and L2, and this is transformer T2, this is G2, generator G2. The fault occurs in the fourth bus. So bus number 1, bus number 2, bus number 3, so this is bus number 4. So fault occurs in the fourth bus. Okay. So now find the symmetrical fault current at bus number 4. So we know the formula for symmetrical fault. IF is equal to pre-fault voltage, okay, divided by Z Thevenin plus ZF. So the Thevenin impedance calculated using Z bus building algorithm. Okay. So very first write the path for this problem. So this is actually grounded. Both the generators are grounded. So 0 to start from here 0 to 1. So the path start from 0 to 1. Next 1 to 2. Next 2 to 3. Next 3 to 4, and finally 4 to 0. Clear? So 0 is the reference bus. 0 is the reference bus. So bus number 1, initially it is nothing but new bus. So reference to new. Reference to new. The second case, step number 2, the bus 1 is now converted into existing type. Bus 2 is new one. So here it's nothing but existing to new case. The next step 2 to 3. So second bus is existing, third bus is new one. So again we can apply existing to new rule. Clear? And the next step 3 to 4. Here also third bus number 3 is existing, bus number 4 is new. So again apply existing to new. Existing to new. And the final 4 to 0. So 4 is existing bus, 0 is the reference. So here we have to apply existing to reference. Existing to reference. So now we can solve one by one. So first 0 to 1, that is reference to new. Reference to new. Okay. So in this case 0.15 is the impedance value between bus number 1 and 0. Clear? So now form Z bus. Z is equal to J.15. J.15. Next, so this is step number 1. This is step number 1, and step number 2. Step number 2 is existing to new. Existing to new. Clear? So now in existing to new we can consider 1 to 2. 1 to 2. Bus number 1 to 2. So bus number 1 to 2, the value is 0.09. 0.09. So this part is over, 0.15. Clear? Now find the Z bus. So now the size of the Z bus is increased to 2 cross 2. And the type is existing to new. So the previous value is repeated in the first row and second row. So same value is repeated in the first row and first column. Similarly, second row and the second column, the value is added with 0.09. So the previous value is added with the values available between 1 and 2. That is J 0.09. So Z bus is 0.15, 0.15, 0.15, the next one is 0.24. Next, step number 3. Step number 3 is two to 3. So now bus number 2 is existing, 3 is new one. Again we have to apply existing to new rule. Existing to new rule. Okay. Now so value between 2 and 3, 0.05, 0.05, 2 to 3. So now form the Z bus. So Z bus equal to, so size of the Z bus matrix is increased to 3 cross 3. So bus building means we can use the previous bus value. So step by step we can build up the Z bus. So step number 2, we can get J.15, 2 cross 2 matrix, the same matrix repeated, but here the size of the matrix is 3 cross 3. So this is the previous result, but the size of the matrix here is 3 cross 3. So repeat the same column repeated in the third column. The same manner, the second row is repeated in the third row. So J.15, J.24. So here also J.15, J.24. And the last value, Z33 value is 2.4 is added with the element available between 2 and 3, that is J0.05. 24 plus J0.05. So Z33 value is J0.29. In the same manner, we have to apply for 3 to 4 and 4 to 5 also. Okay. Next is, in step number 4, we can choose the path 3 to 4. So this is the path 3 to 4. Okay, again it's nothing but existing to new rule. So 3 is the old bus, existing one. 4th bus is introduced in the step, that's what it is, nothing but a new bus. So 3 to 4, again we are applying existing to new rule. Okay, existing to new. So now the size of the matrix increased to 4 cross 4. Actually, another method is also available, but this is the easiest one. 2.4. Yes. So in the third row, so in the previous case we are getting 3 cross 3 matrix. The same matrix we can implement it here also. So this is the previous result, but in this step the additional row and column is added, that is the fourth row and fourth column. Okay, so here the fourth row depends the third row value, so the third row value is repeated in the fourth row. Similarly, third column value is repeated in the fourth column also. Okay, so the same value repeated here, 0.15, here also 0.24, this is 0.29. Then now form the fourth row, 0.15, same third row value is repeated, 0.24, 0.29. the last Z44 value is J.29 is added with the element available between 3 and 4. So the element available between 3 and 4 is 0.09. Okay, so Z44 value is 0.38. Z44 value is 0.45. The path is 4 to 0 is the path. So this is nothing but existing to reference. Existing to reference. So it's similar to existing to new, but the only difference is we are applying a Cron reduction technique. Clear? So initially, size of the matrix is increased to 5 cross 5. So we can use the same previous 4 cross 4 matrix and form the fifth row and fifth column using the additional element that is available between 4 to 0. Okay, so 0.15, first write the 4 cross 4 matrix. It is obtained in the previous result, step number 4. So this is the 4 cross 4 matrix already obtained in the step number 4. So say same value repeated in the steps also. So the last value is obtained 0.38, right? 0.38. So this is the previous values, step number 4 values, 4 cross 4 matrix. Now form the fifth row and fifth column. It exactly similar to existing to new. The only difference is we are applying a Cron reduction after forming the 5 cross 5 matrix, right? Okay. For understanding and change the font color. So the fourth row repeated in the fifth row, 0.15, 0.24 and 0.29 and 0.38. Okay. In the same manner, fifth column, 0.15, 0.24, 0.29, 0.38, and last Z55 value is 0.38 is added with the element connected between 4 to 0, that is 0.15. Okay, so that is Z55 value is 0.53. 0.53. But this is not original size of the Z bus because it formed based on the virtual node. So eliminate the last row and last column using cron reduction technique. Okay, now apply cron reduction technique. So purpose of cron reduction is it eliminate the last row and last column. Why? Because it created by the last one, last column created by the virtual node. Okay. So in cron reduction techniques, the I value is 1, 2, 3, ... n minus 1 because we have to eliminate the last value, that is n equal to 5, fifth row and fifth column, and so I not equal to n, right? Similarly, j equal to 1, 2, ... n minus 1, and j is also not equal to n. Clear? So after applying a cron reduction, we are getting the original value of Z bus, and size of the Z bus is 4 cross 4 matrix. Okay. So what is the cron reduction rule? Zij new equal to Zij new equal to Zij volt. Zij volt minus Zin into Znj divided Znn. So this is the cron reduction rule. So as per the rule, Z11 new equal to Z12 volt minus Z15 into Z51 divided by Z55. Okay, so Z11 new value is Z12 is 0.15 minus J.15 into J.15. Divided by last value J.53. So answer for Z11 new. Z11 new equal to J.1075. Similarly, Z12 new equal to Z12 volt minus Z15 into Z52 divided by Z55. So here Zin into Znj. So I, for example, we can consider starting bus number is I, j is n bus number. So Z12 means 1 is the starting bus number, 2 is the end bus number. So here Zin into Znj, n is 5. So here In 1 5, Nj phi2 divided by Z55. So Z12 new equal to Z12 old, the same 0.15 minus Z15 0.15 into Z52. Z52 value is 0.24. Z52 value is 0.24 divided 0.53. Okay, so Z12 new is, so Z12 new is 0.08207. So Z12 new. In the same manner, Z13 new. Z13 new equal to Z13 old. Z13 old minus Z15 into Z53 divided by Z55. Okay, so Z13 is 0.15 minus J.15 into Z53. Z53 is 0.29. J.29 divided by J.53. So we'll write in the next page. So Z13 new is J0.0679. So this is Z13 value. So next, Z14 new equal to Z14 old minus Z15 into Z54 divided by Z55. So Z14 is again 0.15 minus J.15 into Z54. Z54 value, Z54 is 0.38. 0.38 divided by 0.53. Okay, so J.04245. So this is Z14 new. Z14 new. So here it's nothing but a square matrix, right? So Z21 equal to Z12. Clear? Next, Z31 equal to Z13. Next, Z41 equal to Z14. Okay. So next, we will find out what is the value of Z22 and Z23. So Z22 new equal to Z22 old minus Z25. Starting bus number is 2, n value is 5. So Z25 Zin into Znj. Nj is 52 divided by Z55. Okay, so Z22 value is 1313. The same manner find Z23 new equal to Z23 old minus Z25 into Z53 divided by Z55. Okay, so what is Z23 old? Z23 old value, Z23 value is also 0.24. Then Z53 value is 0.29. Okay, Z23 is 0.24 minus Z25. Z25 is also 0.24 into Z53 is 0.29 divided by 0.53. Okay, So answer is J.1086. 86, that is Z23 new. Okay. So as per the square matrix property, Z32 equal to Z23. Okay. So no need to find again Z32. And one more thing is Z24, right? Z24 new equal to Z24 old minus Z25 into Z54 divided by Z55. So Z24 value is 0.024 and Z25 value is also 0.24 into Z54 value is I think 0.38. 54 is 0.38. Z54 value is 0.38 divided 0.53. So answer is J 0.06792. So this is Z24 new. Z24 new. Z42 is Z24. So the third one, Z31 is available. Z32 is also available. The only thing is we find out Z33, Z43, Z34 we find out, right? So okay, in this next step we find out directly Z33 value and Z34 value, Z33 and Z44 value. So Z33 old minus Z35 into Z53 divided by Z55. Okay, so Z33 new equal to J.1313. Okay. Next, Z34 new. Z34 new equal to Z34 old minus Z35 into Z54 divided by Z55. So Z34 is also 0.29, Z35 0.29 into 54 0.38. 54 is 0.38. 0.38 divided 0.53. 4 new. Z34 new equal to 0.08208. Yes. So next, and finally Z41, Z42 and Z43 is also available. We find out only Z44 new. Okay, so Z44 old minus Z45 into Z54 divided by Z55. So Z44 is 0.38. Okay, Z45 45 is also 0.38. Z54 also 0.38. So Z44 is 0.38 minus 0.38
0.38 square divided by 0.53. 53 is A. So this is the final answer, 0.1075. Okay, so this is Z44 new. So fault occurs in the fourth bus. Okay, so we can consider the Z44 value is the Z Thevenin. Clear? So Z Thevenin is nothing but Z44, that is equal to J.1075. Okay, so this is the required Thevenin impedance value. Why? Because the fault occurs in the fourth bus only. Okay, so now find what is the value of IF. So in this problem, in the given problem, there is no fault impedance value. So V Thevenin divided by Z Thevenin plus ZF. So this is the formula for symmetrical fault current. So V Thevenin, the pre-fault voltage is default 1 angle 0 degree. Okay, 1 angle 0 degree. Why? Because generator 1 and generator 2, in both the case we are getting a 20 kV value, right? So the pre-fault value, pre-fault voltage is also same. Actual voltage and base voltage value is also same. That's what, it's nothing but 1 angle 0 degree per unit. And Z Thevenin is Z44. Why? Because fault occurs in the fourth bus. Fault occurs in fourth bus. Fault occurs in fourth bus. Okay, so that we can consider Z Thevenin equal to Z44. So J.1075. So here they didn't given any fault impedance value. The fault impedance value as per the problem, Z of value is 0. That's nothing but bolted fault. The fault impedance value is 0 means that is called as bolted fault. Okay, so in this problem the Z of value is 0. So that 1 angle 0 degree divided by J.1075. So fault current, symmetrical fault. So IF is equal to 1 angle 0 degree divided by J.1075. So IF value is minus J 9.3023. So this is a symmetrical fault current value. Symmetrical fault current value. Fault current value. And the problem itself they ask, the next one is post fault voltage. Post fault voltage. So post fault voltage, how to find post fault voltage means V suffix I power F equal to 1 angle 0 degree minus ZIF into IF. Okay, so suppose we have to find what is the post fault voltage at bus number 2 means V2F equal to 1 angle 0 degree minus I is bus number. So Z2, this F represent bus fault location number. Fault location number is 4. So Z24 into IF. Okay. Now check the matrix. Actually, after applying a Cron reduction, we are getting a 4x4 matrix, right? After applying a Cron reduction, we are getting 4x4 matrix. This is the final. After Cron reduction, this is the original Z bus matrix. Okay, so this is the original 4x4 matrix value. So based on that we can calculate the fault current. So Z Thevenin value is 0.1075. Why? Because fault occurs in the fourth bus. So Z44 is 0.1075. Fault current is J 9.3023. So using the matrix value, we can calculate the post fault voltage. Here Z24, take the matrix value. So second row, fourth column. Z24 value is 0.06792. So 1 angle 0 degree. J 0.06792 into the fault current value is J 9.3023. Okay, so bus post fault voltage at bus number 2 is post fault voltage at bus number 2 is 1 angle 0 degree minus 0.6318. So final answer 0.3682 per unit. The same manner we can calculate other two bus voltages, that is post fault voltages bus number 3. We can use V3F. V3F is equal to 1 angle 0 degree minus ZIF. So I is nothing but 3, fault location number is 4, so IF. The same manner, we know very well fault occurs in fourth bus, so V4F is nothing but 0 per unit. Why? Because the fault occurs in the fourth bus only. So 1 angle 0 degree minus Z44IF is nothing but again 1 angle 0 degree. So post fault voltage as bus number 4 is 0 per unit. So this is the procedure for finding a post fault voltage and fault symmetrical fault current. Okay, so I can solve now gate question. So this is a gate question paper. So the bus impedance matrix of a 3-bus system, they given the matrix 3x3 matrix. Here they clearly mentioned the fault impedance value is 0.007 per unit. The fault occurs at bus number 2. So neglect the pre-fault loading conditions, the voltage at bus 1 during the fault. That means question is post fault voltage at bus number 1. Okay, so we know the formula for post fault voltage, that is VIF is equal to 1 angle 0 degree minus ZIF into IF, right? So here as per the question we calculate bus post fault voltage at bus number 1. So V1F 1 angle 0 degree minus Z12. So F represents here ZIF, this F represent fault location number. Here the fault occurs at bus number 2, so that Z12 into IF. So this is the formula for this problem. So first of all find what is the value of IF. So IF is equal to 1 angle 0 degree, the pre-fault voltage default it's nothing but 1 angle 0 degree, and Z Thevenin plus ZF, right? So 1 angle 0 degree divided by Z22. Why? Because the fault occurs in second bus, right? The fault occurs in second bus, so the Thevenin impedance is Z22. So what is the Z22 value? Z22 value is 0.093 plus fault impedance, right? So Z22 is 0.093. That is a fault impedance, not fault impedance, that is a Thevenin impedance value. So now find out what is IF. So IF is 1 angle 0 degree divided by Z22 value is 0.093, right? This is Z Thevenin plus fault impedance is 0.007. Okay, so what is the value of fault current now? So answer is minus J10. So this is the symmetrical fault current. So this is the symmetrical fault current value. Okay, now find voltage at bus number 1 during the fault. So V1F is equal to 1 angle 0 degree minus Z12. So take the matrix value. So Z12, so this is Z12 value. So J 0.061, okay, J 0.061 into IF minus J10, okay. So final answer is V1F is equal to, so 1 angle 0 degree minus 0.61. So final answer V1F, final answer is 0.39 per unit. So this is the final answer. So 0.39 per unit. So for this problem, the bus voltage at 1 during the fault, that is post fault voltage at bus number 1 is 0.39 per unit. So final answer. This is one of the gate problem. Thank you. Continue in the next video session.